Hello everyone and welcome back to a new session. In today's session, I would like to review chapter 17, which is Standard Template Library. In front of you, you have a lab that I would like to do, and this will give us a good practice for this chapter. So standard template libraries write a program that opens a specified text file, then appends to the file the count of all unique words in the file, the count of each letter in the file, only alphabets, no commas, periods, plus sign, etc. So no special symbols or special characters, only alphabets. And we have a sample text that we need to try and work on. So let me navigate to Visual Studio, and I will start with first things first. In order to use fstream, I need to include fstream, and then I need to create an object, and then I need to tell my object to open a file called sentences.txt in mode N. So I need to prepare this file. I'm gonna go here. I'm gonna say open folder in File Explorer. So it will open here. I'm gonna create a text file called sentences, and then I will paste our sample text. So here's our sample paragraph. Looks good. Minimize, close, close. So now that the file is ready, as we remember, we need to do 4 main tasks. Whenever we are working with a file, we need to open the file, make sure it opened successfully. We need to process the file, and then we need to close the file. So this is done. Now I need to make sure that it opened successfully, which is something like this. If my input file dot is open, and this will simply tell me if it got open or not, then I'm going to display something wrong with the file. Terminating. So when the file is open successfully, I'm gonna go ahead and read the entire paragraph to a string object. So I'm gonna say string my paragraph, and then I'm gonna say get line from my input file to paragraph. It's not recognizing this, so let's include a string because I'm using strings here. And then now that this step is done, I'm gonna go ahead and test it really quick, which is recommended to test, to basically build your program in pieces and then test each piece separately. So now this is the input file, and this is the paragraph. I see that it loaded it successfully, so I'm good in this part. Then what I'm gonna do is I'm gonna start processing this paragraph. So it needs me to populate the count of all unique words in this file. The fact that unique is mentioned and the count, that means the best data structure in this case would be a map. The word would be the key because it has uniqueness in it. And then the value, remember the map, it has each item in a map is a per key value element. Each element in a map is a key value per. So in this case, the key would be the word, and then the value would be the count of that word. So let me go and prepare it. So in this case, I'm gonna put it here. So I'm gonna say I need a map that has word as a string and int as count, and then I'm gonna say words map. It's not recognizing map, so let's include map. And then the next thing it needs me to do the count of each letter in the file, which would be the same. So I need a map from, in this case, character to an int, and then I'm gonna say chars map. So I have my paragraph ready. So I'm gonna go ahead and start populating from that paragraph into my maps. And then on each occurrence, I will add that item to the map. And since the key is not there, the first time I add to the map, the count would be 1. And then the second time I add to that map, the key would exist, so the value should be incremented. In that case, I'm going to use what we saw as a shortcut, which is the increment operator, and I'm going to show you how I'm going to do it right now. So I can say for int I equals 0, I less than whatever my paragraph dot size is, and then I plus plus. This will iterate my string, which is the paragraph. And then I need to stop reading each time I encounter a space, because I'm basically, if we open the file in front of us, this is the file. So I'm iterating this string, and I need to keep track of each word and put it in the map. So I'm going to iterate from the beginning all the way to the end. And every time I encounter a space character, I'm going to add what I already read so far to the map and then start over. Add, stop, add to the map, sorry. We're going to start from here. Populate, and then, oh, space. Okay, so add what I already populated to the map and move on. Reset my temporary word or current word, and then add to the current word, space, add to the map. Meaning, I'm going to have a temp string. I'm going to create it here. I'm going to call it L current word. Then I'm going to say this current word starts empty. And then I'm going to say if L my paragraph at this location is the space character, every time it's the space character, L words map at L current word increment. Yep. Otherwise, in this case, I'm gonna reset current word, and then I'm gonna continue. Otherwise, if it's not space, then it's a letter. So I need to add that letter to my word and my paragraph at I. Let's see, from I0 to the end, if I encounter a space, I'm gonna add what I have into my map, and then I'm gonna reset current word, and then I will start over. Otherwise, I will populate word. So it's gonna start from here. Is this a space? No. Then I will be added to current word. And then we're gonna continue to the next iteration. Is this a space? No. Then F will be added to current word. So now the current word variable will have if. On the next iteration, it's a space character. The fact that it's a space character, we're gonna grab what we have in current word so far, add it to the words map, and then we're gonna tell current word reset, you're gonna start over, and then go to the next iteration. On the next iteration, this is not a space, so it will be added to current word, which has been reset, and repeat. Space, meaning add to the map, reset current word, and continue. Populate current word, reset current word. Populate current word, reset current word, and so on. So let's display in here just as a test. So test map population, or populating the map. So what I'm gonna do is I'm gonna prepare an iterator. Begin equals L words map dot begin, and then L iterator end equals L words map dot end, and then I will just use a loop as long as I didn't reach end. So for I already populated L iterator begin, and then L iterator begin is not equal L iterator end, and then L iterator begin plus plus. On each iteration, I'm gonna see out the word L iterator begin first, and the count, which is the value of it. L iterator begin second. So let's test it. I'm gonna go all the way here. Actually, let me show you how it's gonna work so we can see it together. Okay, so I have my paragraph. Here it is. Then I am at the first character, which is I, and then I am at current word, which is empty at this point. And then my paragraph, sorry, my map, which is here, has size 0. So is it a space? No, it's an I. Okay, so add it to current word. Here it is. Next iteration, is it a space? No, it's an F. Okay, add it to current word. Here it is, if. Now it's a space. The fact that it's a space, I'm gonna tell my map that I need to add this character and set its value. Let me review this statement for you. This operator here, if I pass it a key that does not exist, then it will create that key and set its value to be 0. This is what this operator is going to do. At this point, map is 0. It has no pairs, it has no keys in it. I'm passing it a key that doesn't exist. So the map is going to create that element. It will set the key to be if, and then the value to be 0. Then I'm calling the increment operator on this key, meaning it will increment its value. This is how this does it. This operator here, if you remember, returns the value of that key, right? If I open, for example, Paint, and I have my map, for example, that has, let's say, letters. It has A, count 10. It has B, count 15, for example. C, count 5. If I say C out, my map at the character A, this statement right here is gonna display 10. This operator will return the value at that key. So when I do my map at A plus plus, the 10 will increment and become 11. Here I am incrementing the value. This returns the value of that key. This is the value. This is the key. So this returns the value at that key, meaning it will display 10. If I use the same expression, I will get access to the value, and then I'm executing increment operator on that value. So the 10 becomes 11. So back to this, I'm doing exactly the same, except the difference here is the key doesn't exist yet, but it will sort itself for me. The fact that the key doesn't exist yet, it will create that key and will set its value to be 0. Then I'm executing increment operator on it. The 0 will become 1. And that's exactly what I need. At this point, the current word if was encountered once. So I need the value to be 1. F10. Here's the map. Now it has the key if and the value 1 means it was encountered. Now the next time we encounter an if, this expression will return or will give me access to the value of that key, meaning the one of the if, and it will execute the increment operator on it, so the value becomes 2. So every time I access this key, I'm incrementing its count. So now that I added this current word to my map, I need to reset current word because I'm starting over and then continue. So now the next word starting by Y, populated. So O, populated. So now current word is YO and the current letter is U, continue. So now I have a space and current word is U. So I'm gonna add it to my word and then continue to the next item. So go ahead, add current word to my map and increment, continue. So now my map has size 2, which I can view. Here it is, U has been encountered once. If I keep doing this and then I reach the testing, I can look at my map and I can find that the size is 71. I can display, I see C++, comma, for, if, whatever, 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 there you, adventure, So let's see what was written in here. Earlier, then you have really been, there are zillions of things. For example, you could do a custom version. Oh, here it is. Okay. So it wasn't like an error. It is an actual word. Sudoku and Mahjong with your own images. You could da, 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 da. So looks good to me. We read each word except for what I see plus and commas, because every time we end, let me stop looking at this and let's look at this. Every time I reach the end of a sentence, the comma is part of the word. So I need to make a special case where I ignore commas and also ignore periods, because the space is after the period. So IT period would be included in the word and added to the map. So I need to take care of that. What I can do is, there are several ways, but for me, the best way to do this is, let's ignore and continue. So done. Let's close. So what I'm gonna do is, every time I'm about to add a word, I will check if there is a comma or a period and strip them out. That's what I'm gonna do. So I'm gonna say, if current word dot find, it has a period. If it has a period, or if current word has a period, or current word has a comma, then what I'm gonna do, I'm gonna say current word becomes substring. So I need the substring from 0 to size -1. Let me display it for you so you know exactly what I'm doing. So for example, we encounter the word C plus 0. This would be 4 characters. So I'm telling my program, if the word has dot, then I need from, so this is 0, 1, 2, 3, and the size is 4. What I need from this string is the substring 0 to 4 minus 1. Meaning I need you to strip from 0 all the way to 3. So let's do that, and the syntax would be that current word dot substring from syntax from index 0 to current word, whatever size of this -1. Let's test it. Let's go all the way to here and run it. So I see that it's still doing it. Let's see. This would return. Oh, I know. So I need to say the correct syntax for find. Find would be if std string npos. This is what I need. So if find is not the end of the string, meaning similar to how we search in map, if you remember, when you search into a map, you're gonna say map find is not end. If map find is not end, that means it found it. Otherwise, if it doesn't find what we're looking for, then the find method will return end of the map. So similar. Here we are saying if this find succeeds, then it's gonna return the index of the period. Otherwise, it will return the end of the string. So if find doesn't return the end of the string, that means it found it. Same if find, oh, these are the same. Otherwise, or not otherwise, or if this find doesn't return the end, that means it found a period. So meaning, if I find a period or I find a comma, I need to execute this statement. Redundant code, yeah, I fixed it. It was, both of them were periods. So let's go here and find the first current word that has a comma. Here it is. So I need to substring from 0 all the way to size -1. So current word will become, here it is, C++. So I stripped out the comma. Continue. So now I have 71, and let's see. So I don't see any dots or commas. Good. And then current word became, this is probably from previous, so it was displaying current word before we stripped it out, but it does strip it out before we, oh, you know what that is? If it's a space or new line, because I noticed this is the end. So here is a new line or the file end. It's not space. So here I need to say if it's a space or it's a new line at I equals new line, or let me do this, and let me also close the file. So L input file dot close. See why commenting the steps is helpful, because you don't forget anything. So start, what is in it now? It still read this, and 71, it has the C++ in it. What, you know what I can do just for now, because this is, I don't want to waste a lot of time on this piece. What I can do is go here, go here, go all the way here, and then say enter. It's not a space, so it will dun 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 dun. Yeah, when I go out of it, if L, when I go out, that means the file ended, right? The paragraph ended, but current word might still have value in it. So I'm gonna say same. If L current word is not empty, do the same like here and add it. This will fix it. This will fix it without doing a new line. So like this, space. Notice, look, I'm gonna stop here. I was doing the same thing, but once I'm done with my paragraph, I said, hey, if there is a word in current word, if there is a value, check if it has comma or a period, substring it, and then add it. Because what's happening is I have the sentence, right? Whatever the sentence is, for example, do in C++. So I have this. So we have this, right? Once we are reaching here, current word has a value in it. It has C++ dot. However, we're breaking out of the loop and we are not using this. Now it happens that we have C++ somewhere else, so the C++ will be in the map, but this count will not be taken into consideration. And we need to take it into consideration. And if it's a unique word, we also need to add it to the map. So back to here, this will take care of it for us and after the loop. So now, for example, notice we went out of the loop, right? However, current word has a value, which is the very last item. So notice C++ will say value is 1. However, it was encountered twice. Once, twice. So I need to fix it. And this is how I fix it. I'm stripping out the comma and period and then adding it to the map. So now it's correct. C++ has been encountered twice. So this has been fixed and this has been tested. I'm gonna display just so we see it nice. Here it is, C++ has been encountered, A has been encountered 6 times, could has been encountered 5 times, make, etc., etc., etc. So the first step of my lab is done, which is the count of all unique words in the file. Perfect. Next is to keep track of all unique words in the paragraph. So what I can do, I can integrate that into my code, meaning this is the characters map. So here I'm checking if the character is a space or not, right? So before I add the character, or not before, it doesn't matter, but here at this step, I am inspecting this current character and adding it to current word. So what I can do is I can populate the current character into the characters map. So add the current character into characters map. So what I can do is I can say Charles map, same, at whatever current character is plus plus. This will take care of it for me. So I'm gonna go ahead. Actually, we need to also do it. And then, no, this will take care of it. Because once I reach the end, I'm adding that character to my map. So I'm good. Let's test it. Let's break here and run. So now I'm gonna hover my mouse. I see 38 characters. So 38 characters. I should see 26, obviously, the English alphabet. So we need to take care of special cases. I see emptiness, the emptiness character. Well, not the emptiness. This is single quotation. Single quotation, because we have like can't and I see. Here it is. Can't. What else? Can't. Yeah, so back to this. What I can do is I can do it in a quick watch. So size is, no, not current word. We need Charles map. Charles map. Here it is. So single quotation has been encountered twice. Plus, comma, dash, period, CF. Oh, so notice, for example, we have a capital C and we have small c, and we need to consider them as one. Capital C is the same as small c, because these are the unique characters. So the first thing I need to do is I need to say convert this to lower always. To lower this character always. Meaning if this character here, if this character is a capital C, I need to convert it to a lower C. If it's a lower C, then it's a lower C. So the C and anything else will always be added as lower cases. So all cases will be treated the same. Whether it's an upper A or a lower A, it will be added as a lower A. Or I can do it to upper as long as I switch them to one of the cases. To lower or to upper will work. This is one thing for taking care of those characters. So let's try again, run. So now it has 30. Let's see what's in the 30. It has these special characters, and then I have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. There's no Q. We didn't find a Q. And we can confirm it by searching here. Is there a Q? So there is a Q here, which is not part of the text. And there is a Q here, which is not part of the text. So good. Q, R, S, T, U, V, W, X, Y, and Z. So perfect. We found a lot of characters, but I need to ignore these characters, so the special characters. A good way to do that is I can do it at the display level, meaning at the results step, or at the reading step. The question is asking me to append to the file. So it's asking me to append to the file the count of each letter. I can only count before I append, or I can count when I populate, meaning I can count or I can cover the case of symbols at this step, or I can cover the case of special characters right before I append to the file. It's really based on your preference, whatever you want. I can do it right before I append to my file, or I can do it here. What I can do is, here's a smart thing to do. I'm gonna open ASCII code for you. ASCII table. Images, open ASCII table. Notice that special characters, or if you want to look at it in a different perspective, the characters we care about are A to Z, which has the decimal value 65 to 90. That's if it's a uppercase. If it's a lowercase, then the decimal 97 to 122 inclusive. So I can tell my code, hey, after you convert to lower, if it is within 97 and 122 inclusive, then add it to the map. Otherwise, do nothing. Don't add it to the map. So I'm gonna cut this. I'm gonna say char L current char equals this, right? To lower. And then if L current char as a decimal, I can just use decimal. So if this is greater than or equal 97 and L current char less than or equal 122. If this is the case, then yes, add it. So like this, like this, L current char. Here it is. So now go here, continue, restart. So L current char is I, so it is within. Good. Go, 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 go. Let's see the end result. Continue. Oh, nope, nope. Get tools and features. I see. I was looking for this the other day and I thought it's called installer, but it's called get tools and features. So continue. I'll charge map. So now I have 25. Size 25. Good, because alphabet is 26. We don't have a Q, so it's 25. A to Z without Q. Perfect. So this worked. This is the code working. So now I'm closing the file. So right before I close the file, which is here. So I did my map, I did my characters. So here I need to append to my file. What I'm gonna do is, notice that at this point I did get line, right? So I did get line, meaning the pointer when I opened the file was looking here. Now that I did get line, so now the pointer is pointing here. So what I'm gonna do is I'm gonna rewind my pointer. Well, I don't really need to rewind because it's asking me to append. So I'm gonna add to my file, or I can, in a smarter way or a cleaner way, close the file and then open the file in append mode and then add whatever I want. So and that's what I'm gonna do. So close the file, right? I'm gonna close the file. Then I'm gonna open the file again. So I'll input file dot open, but this time I'm gonna open it sentences dot text in append mode. So iOS append mode. What am I going to append? I'm gonna append the count of all unique words, similar fashion that we did. Did I delete that code? We deleted that code, so we're gonna write it again. So append words count, append letters count. So auto L iterator begin equals L words map. Oh, it was declared inside. The declaration is not accessible, so let's move this to the outside. L words map dot begin auto L iterator end equals L words map dot end semicolon, and then for I already did it. Iterator begin is not L iterator dot end semicolon L iterator begin plus plus. Then on each iteration, first I'm gonna L input file and L, just so we see it, and then L input file, L input file. Let's do manipulators. So set W10 L words map, or no, L iterator begin first. Or plus, and then the count will come Actually, let me do it like this. It would look cleaner. And then iterator begin second. And now it's not recognizing set widths because it needs the IOmanip library. So come on, suggest. It's not suggesting. So let me go and add it. So include IOmanip. So now it did it. So let's close the file and test this section, which is here. So start. It's gonna go over it and do it and then close the file. So let's open the file now. 3 sentences. Here it is. So I need to align left. Looks nice. I'm gonna say left. Oh, it didn't align left. Why? Strange. Maybe after. Try again. Oh, is it adding now? Oh, it keeps adding. No, wait. Close. So it did work, but it added it. So let's undo these and start over. Save. So this worked. Go. Open. Here it is. Perfect. Let's add a space to the second. So space like this. So now let's do it again. Sentences. So this is one part. Start. Here it is. Looks nice. Now we're gonna do the letters. Same fashion. Close. Close. So append the letters. We're gonna copy, paste. This would be L characters map. L characters map. We're gonna add new lines, and then we're gonna set width. Since it's just a character, so I'm gonna just set width to let's do 3. Iterator begin. Iterator. This has already been declared. So let's do 1 1. Iterator begin 1, begin 1, begin 1, begin 1. Iterator end end. Boom. Let's go and see it. So here is the character, the letters, the word, and here are the characters. Perfect. A to Z. So I need you to basically practice something like this, right? I'm not going to ask you to build this program in the test, but I need you to know how to use FStream, how to use maps, because this chapter is STL. It's standard template libraries, and maps are a big part of that library. So I need you to know how to use maps with FStream. Eventually how to get data from the file, how to loop, how to populate a map, some logic with the strings and characters, and then how to iterate a map. This is how I iterate a map. Yeah, so let me know if you have any questions, and good luck.